In section 4.1, we're discussing the measures of center, and there's three ways of talking about the measures of center. We can find the mean, the median, and the mode, and it's a typical value. Now, for objective number 1, we're going to compute the median for a set of data. The definition: the median of a set of data is the 50th percentile. So, the procedure is to find the median of a distribution. You're going to list the observations in ascending order, which is from smallest to the largest. Now, if the number of observations is odd, then the median is the middle number. Now, if the number of observations is even, then you add the two middle numbers together and then divide the sum by 2. So, let's take a look at the first example here. The first example tells us that we want to be able to find the median for the following sets of data. Well, the first thing we need to do is to put this in ascending order from smallest to largest. So the smallest number is 17, and then the next number is 20, and the next number is 28, the next number is 28, and then the next number that we have is 31, and then 32, 43, 53, and then 90. So, because there are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, that means that the number of the observations is odd. Then the median is going to be the middle number. So, since we have 9 observations, 1, 2, 3, 4, 1, 2, 3, 4, and the middle number is 31. So the median in the first example is 31. Let's take a look at the next example. So again, for these numbers, we want to put them in ascending number. So from least to greatest. So the smallest number here is 6.2. The next number is 6.3. The next number is 7.5. And then 9.3. 10.4, 12.6, 13.4, and then 15.6. So let's count out these numbers. 1, 2, 3, 4, 5, 6, 7, 8. So if the numbers of observations is even, which is even, we're going to add the two middle numbers together and then divide the sum by 2. Well, let's take a look at the two middle numbers. Well, the two middle numbers are 9.3 and 10.4. So in order to find the median here, well, that is taking 9.3 plus 10.4, and then we need to divide that by 2. So we're going to take 9.3 plus 10.4 and then divide that by 2. which gives us 9.85. I'm going to round that to 9.9 because our data was given to the 1 decimal place to the right. Okay, next example, part C. We want to be able to find the median of this. So let's go ahead and write it in descending order. So the first number is 6.2. And then 6.3. 7.5. 9.3. 10.4. 12.6. 15.6. And then 90.4. So let's count up our numbers. 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we have an even amount of numbers. If we have an even amount of numbers, then we need to take the middle 2 numbers and then divide it by 2 to find the median. So the 2 middle numbers are 9.3 and 10.4. So let's find the median here. So the median is 9.3 plus 10.4. Divide that by 2. So what do you notice in this example, in the previous example? Well, we're using the same numbers, but there's a number that's listed in there that's not the same as the previous one in part B. So we're still going to get the same result as 9.85, which is approximately 9.9. Okay, now the one thing we want to now look at the definition here is an outlier. So for now, an outlier will be defined as an extreme value. That is, in a set of data, an outlier will be an observation that is much larger or much smaller than the rest of the data. We will learn more about precise definition later. So, which one is an outlier in our example? Well, our example is 9 with 90.4 would represent the outlier. And if you notice, they replaced the number 13.4 in part B. So in part D, it says, what do you notice about the sets of data in parts B and C? Did it affect the median? And what do you think this means about the outliers and its effect on the median? So the first part says, what do you notice about the sets of data for parts B and C? Well, data set C includes the outlier 90.4, which is what we pointed out in part C. Now the next question is, did it affect the median? Well, no, because the median stayed the same at 9.9. Now, what do you think this means about outliers and its effect on the median? Well, outliers do not affect the median, and therefore we can say that the median is resistant to outliers.